Hi everyone. In this video I just want to talk about the bond supply curve. And we're going to make its derivation very simple. Let's think about a period of time which is just one day. Right? And on any given day, whether you're talking about corporate or U.S. Treasury securities, it doesn't really much matter. The supply of bonds is fixed, which means it's perfectly inelastic. So we're going to have a bond supply curve that looks essentially like this. Okay? It's going to be vertical at whatever the stock of outstanding bonds are in the economy or circulating in financial markets right now. So at any given point in time, fluctuations in the price of bonds won't affect the number of bonds that are on the market that particular day. You know, it takes time for corporations to make the decision to go ahead and issue new bonds, register the securities, go ahead and issue them, etc. Likewise, it takes time for the government to make the decision, we need to borrow more, and then to go ahead and issue the securities. So on any given day, for simplicity, we'll just go ahead and say the supply of bonds is fixed. All right? Well, if that's the case, we need to ask ourselves, well, what's going to cause the quantity of bonds in the marketplace to change over time? Well, again, we need a thought experiment, and we'll work with expected inflation. And I'll just go ahead and pick a price of bonds, and we'll call it $900 like we did before. And we'll say this is where we are at this point in time, which is we are at point A. And let's say these are bonds that have a face value of 1,000. So, and we're talking about 1-year U.S. Treasury securities. And let's just say the current expected inflation rate is 2%. Okay? Now remember, the real interest rate, which is the real cost of borrowing, is the nominal interest rate minus the expected inflation rate. Or the ex-ante real interest rate is the nominal interest rate minus the expected inflation rate. So once you know that the face value is 1,000 and the price of the bond is 900, you know the nominal yield to maturity, or the nominal interest rate, is 11.1%. So in this case, the expected real interest rate would be, or the ex-ante real interest rate would be 11.1% minus the 2% expected inflation, or 9.1%. All right, that's the real cost to the U.S. government of borrowing to finance whatever it's doing. Or maybe it's easier in this case to think in terms of corporate bonds. So that would be the real cost of borrowing to a corporation to finance investment. So let's ask ourselves, what happens if, so let's just put it over here. It's 11.1% is the nominal interest rate. The real cost of borrowing is then 9.1% because it's 11.1% minus the expected inflation rate of 2%. So what's going to happen if the expected inflation rate, and let's say it goes up to 5%. Okay, I don't care why, I just say the expected inflation rate increases to 5%. What's going to happen to the quantity of corporate bonds over time? Or the quantity of corporate or bonds that corporations want to issue? Well, let's think about this. Well, as in our thought experiment, we're going to keep the price of bonds fixed at 900, so we have a reference point. So if the price of the bond is fixed at 900 and the face value is fixed at 1,000, then the nominal interest rate, or the nominal yield to maturity, is fixed at 11.1%. Okay? So if the expected inflation rate rises to 5%, then the ex-ante real interest rate has fallen to 6.1%. That means an increase in the expected inflation has reduced the ex-ante real cost of borrowing. So if you're a corporation and the real cost of borrowing has fallen, you're going to want to do more of it. Right? How much more? I don't know. Let's say it's B2. So this is the quantity of bonds the corporation is going to want to issue. So they'll be at point B. All right, well, point B is clearly not on the initial bond supply curve, bond supply curve 1. So the bond supply curve clearly has shifted to the right, from bond supply curve 1 to bond supply curve 2. Oops, there we go. So if you think about it, if you increase expected inflation, that's going to shift bond supply right. Similarly, if you decreased expected inflation with a fixed price and a fixed face value, then that's going to increase the real interest rate, which means it increases the real cost of borrowing. So that's going to cause corporations to borrow less, so the bond supply curve is going to go ahead and shift to the left. Okay? Now, there's lots of other things that are going to affect the bond supply curve. For example, taxes can affect it, expectations about future profitability, but it's all going to hinge upon, this face value. How valuable is that $1,000, or how valuable is this $900 to the entity that's borrowing, and how costly is that $1,000 to pay back? Okay, so that's the nature of the thought experiment. So when expected inflation increases, paying back $1,000 a year from now is less burdensome, so hey, let's go ahead and borrow more. But when expected inflation falls, paying back that $1,000 is more burdensome, so let's do less of it. And so that's the nature of the thought experiment. Alright, so the next video will be about equilibrium and shifts in the bond market.